Okay, section 3.2, question E14, little advance warning. Do not do this problem when you are hungry. So we do have some authentic data again, although it is a bit outdated. I think it's fair to say that the companies don't change their recipes too much, although I guess Domino's or Donato's, one of them did change their crust recipe. So maybe these are still up to date. We could probably find the actual data fairly easily by going to a more recent version of Consumer Reports if we were interested as a pizza connoisseur. Okay, so we have the fat counts and calorie counts for 5 ounces. It is important to look at how they're measuring the data here. So they didn't do it by slice because the slice size is different. You have different thicknesses, so we are going by weight here. And we have a regression line given to us already. Whenever we see this hat on the y, that tells us we're looking at a predicted value. In other words, that's the line that's best fitting the actual data points that we have. And we also want to check right away what our y is and what our x is in terms of the variables. So here we're looking at the y-axis. So we're predicting calories from fat counts. Okay, so given the fat count, can we predict how many calories the pizza will have? And that's a reasonable prediction, which is why we do have a pretty good correlation there. So we want to look at 10.9 grams of fat first of all. So again, 10.9 will be our x value because fat is on the x-axis. So let's grab this calculator here, and we're putting them in this equation. Just because I'm not sure how it's going to handle this and I don't have parentheses on this, I'm going to start on the right side here. So I'm going to put in 14.9 times, and then my x value here is 10.9. And I'm going to hit enter to get an answer. So 162 there, and then I'm going to add that 112 from the beginning to get 274.41. They do want to round to the nearest whole number, so that rounds down to 274. You would do a similar thing with the 16, just plug 16 times 14.9 and then add 112. I won't go through that. And finally, we have the slope of the line. So how can we tell the slope of the line? Well, we just look at the equation for the line. Even though you may be used to the form y equals mx plus b, the important part isn't which comes first, it's which is actually attached to the variable, because that's going to control where our slope is. The lone number sitting out there will control where it hits the intercept. So we would get 14.9 as the slope here because that's what's attached to the x. One thing I do want to point out, you may notice, okay, let's extend this line until we hit the axes. This should be about 230. So why are we getting a y-intercept here of 112? So the reason that is because this is not 0. If we were to actually extend this out to 0 and the y-axis down to 0, so we're going to draw a new set of axes where 0 was actually where the two axes came together, and then we extended this line, it really would cross at 112. So it's just kind of an optical illusion there because we're cutting off at 8. That is something you should be aware of as you look at advertising, marketing things in the paper, online. Always be a little bit wary when the origin, 0, 0, is not the place where the axes intersect, because there can be misinformation being given there.